Hello. I am going to bring the tropical paradise into this kitchen here. All right. I even have this painting which I made and quickly scoot across. Quickly scoot across. And where have I hidden it? And come back. Come back. Fade away. And back again with this tropical paradise. And this dress is all brings you to the tropics. I thought I would do a swimsuit and a sarong, but this is chemical engineering, and I would never go to work or meet my professors with them unless I ran into them on the beach, which could happen. You professor. And there I am, in my sarong and my swimsuit, feel a little uncomfortable, I think, because chemical engineering and but my swimsuit, is not a bikini. It's all good, so okay. And as a shopaholic, check this out. I have set 3 glasses, and this is experiment time. And I have bought two sources from where I bought these little umbrellas. They would sit well as a as a as a yeah, adornment on my hair, a little bit of embellishment, bringing to the tropics. So we're settling for this. Okay, my sandals are Hawaiian sandals, purchased in the Hawaiian sunset, which was all sunny. So I have a song in the end, bringing to you the goodness of the sunshine. All right, because the East Coast is picking up. So what goes into this tropical cocktail? First, the chemical engineering. 3 speeds. All right, 3 speeds. First speed, low speed, velocity, change in velocity, which is acceleration. But here, with all the ingredients going together, it's shear stress. And 3, change in shear stress with respect to change in, the depth here, because x del x, in x direction, that would be pressure, change in pressure per unit length. So, change in shear stress would be, I don't know, moment of flux. We will look at while as I'm progressing with the experiment, this book, which was recommended to us by Professor Trass and before in my undergraduate schooling, and of course Professor Cher. So, Transport Phenomena by Bert Stewart and Lightfoot. And let's get started. What's going in? Exact amount, 50 mil, 50 mil, 50 mil. I poured a little bit of vodka. I mean, I met this gentleman. My husband had forgotten his wallet, and when we were in Cancun, we were having breakfast, and it was all an inclusive package. And he said, "Oh, my wallet underneath the pillow," and I charged outside. Let me get it, because the cleaning staff could come, and you don't want. You can leave things in the safety deposit box. So God forbid, but they're very good people, all the cleaning staff. But you mustn't test their honesty, I mean, so I was, and this gentleman was getting a drink, 11 a.m. in the morning, and lounging on the beside the swimming pool. He had a wife, otherwise, a little bit of. Batting of my eyelids, maybe I would have done, or fluttering of my eyelashes in the rush. The wallet had to be picked up, but he said he had a wife. Alas, well, another gentleman sometime, and I go, really, sir, and that might be nice. So, anyways, so today, just a little bit of vodka. That's the only hard liquor left. There's wine, but so about 10 mil, maybe 15 mil at the most. I just poured it. So that's not that's minuscule in volume in comparison. So these will get 50 mil each. All right. So 50 ml of mango juice going in. All right. And then freshly cut pineapple is that time of the year here. Yeah, yeah. 50 ml. Do the 50 ml of mango juice. 50 ml of mango juice. We'll have to shake it. Shake, shake, shake. All right, I'm going to reduce them. It's a little. So, this is not an experiment. All right. I think I put in a mill more. But then in the and I'm going to add pineapple. 3 slices. All right, 3 slices of pineapple. Or add it all. Make it a real tropical paradise. Maybe 3 slices are enough. And water, 100 ml, I'll add 200 ml. How's that? 200 ml of water and an ice cube. 200 ml of water. And okay. And speed 1, velocity, low speed. All right. So I'm going to calculate. This is on camera coming to you on YouTube. 1 ice cube. And YouTube does it like no one else. Not even TV. Well, TV is going to find it hard to compete. Let's see CBC tonight. Let's see. All right, I'm going to submit it to CBC or City TV. Okay. So I have to remember. All right. Low. All right. Low. And 3 shakes. I went to 4 shakes. 4 shakes. So 4 shakes. That's I think seconds there. And first glass gets 15 ml. So my experiment here is going to determine what's the right consistency, viscosity for the cocktail to go through the straws. I have straws here, steel straws, which can be picked up in no frills. Right, because sometimes you find you're sucking air. And when you're not really getting the cocktail in. So I'm using the glass then. So orange comes here first, 50 ml. Okay, now, and I'll do the actually chunks of pineapple with the 2 to 4 shakes. There's a timer kind of thing. I think it's seconds, medium level. Okay. So what is this all going to come up to? All right, this is velocity. So I'm setting up an ODE here with these 3 glasses of different consistency cocktails. All right, tropical. Nobody goes to the tropics. And this is good. This is because I didn't account for the pineapple. It's going to be more, but I'm going to I measured only 50 ml here. So it's okay. That the rest can stay there. I don't need to empty the blender. All right. This going up. Oh, this is not good. I slip. All right. Yeah. Sorry, I could slip. I'll just quickly put a paper down here. Okay. All right. Okay. Hi. Right. right, lower meniscus. This is getting, it's all getting more and more foamy, as you can see, which means, well, it's mixing well, and hmm, what could it be? Foamy. Sodium lauryl sulfate is getting produced. Well, that's what goes into soap, right? So some edible, maybe a little more. This is not quite 50 mil lower meniscus. This is 50 mil, and this gets in. All right, 3 glasses set together. Okay, we get the straws. Straws. And actually, you should always drink it. Served as served in a restaurant. Here in Toronto, we can always afford the tropics, can you? Hawaii, Cancun. Now, vacation time is also hard. School's still going on. And this should have chunks of pineapple there. All right, chunks of pineapple. Small chunks. All right, maybe Marichuana cherries again. So here goes. We put the straw in. And I'm going to tell you how it is, but you should try this experiment at home. And then we are going to figure out, I'm going to figure out for you what this all comes up to. So this is VX, or VY, I think, more taller jar, and cylindrical coordinates, or the blender is actually Cartesian coordinates. So we have x and y, x and y coordinates, but I would just take the depth, right? So y. So Vx, Vy, del Vx by del y, shear stress, multiplied by viscosity, of course. And the third one is del square Vx by del y, del y square, del square Vx by del y square, and that's equal to pressure by Len. So, but I beg your pardon. So, what would it be? So, this is the right speed. I beg your pardon. Oh, this is not even coming up. Not even coming up. Not good. Not good. All right. This is not right. So must drink it. The orange is not working. This is right. But it's stopped. The foam here, the drink, interesting. But the foam could get stuck in the straw. I need a little bit to see. So it tastes better. Well mixed, micro mixing, all good stuff, chemical reaction engineering. That's good. So momentum transfer. So this is all blending into running a process, chemical process. So micro mixing and the reactions taking place, the best tasting, moving through the straw, moving through the reactor into the separator if need be. And the distillation column, and that all works in. I finished it. So that was good. So what does this all come up to? So del Vx, gonna put this away, dollars. So del Vx, so pressure change in shear stress is equal to change in pressure, P naught minus at the top, change in pressure by the unit length So change in pressure, change in shear stress, change in pressure. Actually, this book does not lead it there, you know. I know I looked at all the worked out examples. Once I was auditing this course, math department math course, taught by Professor Seiko, who wouldn't mark my exam at all. And I was negotiating even with him even a couple of years ago for a nice letter sent to the department. But I never paid. So, so fair's fair. He wouldn't mark it. But I would go and sit and in the class, an exam there was only one exam, take home exam. And I was looking into all the books in the math library. And I ran into this guy who was also looking for all the answers. And one little note yesterday, the Sturm Liouville problem, Green's function. I took two math courses from mechanical engineering, engineering analysis one and engineering analysis two. One taught by Professor Thomas, and two, and I was the only one who turned in a mathematical solution. I'm positive for the tough problem he gave. Two was a Professor Rahimi. I'm so sorry. One class I dozed off a little, Professor Rahimi, but I'd gone for a heavy lunch that was an Indian buffet, and my friends from undergraduate degree, but they were not undergraduate degree. They were a year older. They would come to cross the border to get your visas, the work permits, right? H4, H2, all of it. H4 is the wife's visa. H2 and Sriram and the two of them, the friend and his friend, he never stayed. He just met us for lunch. That's it. Some of them used to come home and everything, but this guy was not into that sort of thing. So we just met him briefly for lunch, and Sriram sort of, it was on Sriram. Back in Bangalore, teas used to be on me and little knickknacks when my mother had them ready. But he had treated me once for a nice lunch, and Sriram, of course, we were hosting. He was visiting Toronto, but no, somebody who, this was a close friend, somebody who doesn't, so you should go easier as the years progress, because sometimes you don't know them and it gets a little. But anyways, I went and after lunch, and then I don't know, I dozed off in the class. But he taught us Green's functions, and Professor Thomas, he taught us how to use mathematical. All right. So this in this class there was another guy white guy who wanted to go and work in Madras. Why? Or Bangalore. Bangalore is a bit cool place. But Madras, the man had some serious piece of fluff from Madras tucked away in his home. White guy. Okay. Anyways, yeah. And yeah. So what would this amount actually? I was hoping that I would be thinking, and what would come the answer? Exams. This is a nice question to put away in an exam. All right, so I'm going to think. Shear stress. Okay, more. So we'll just stick to Cartesian. All right, it's easier. It becomes more complex, cylindrical. Navier-Stokes. Let's look at the Navier-Stokes equations. What do they say? Navier-Stokes. All right, Navier-Stokes. For those of you who don't know chemical engineering, these are non-isothermal flow. Non-isothermal flow uh, but non-isothermal would not be right. Mhm. Sorry, I should be more organized. But the whole fun of it being spontaneous, you learning as you progress, as I progress, would not be. Where's the Navier-Stokes equation here? All right, here. Newtonian fluids. So this could be classified. There's water here, and it's just mango juice, and so Newtonian fluids, and Non-Newtonian would be polymer plastic, you know, the, because when they're making it, yeah, when they're making it, and so equation of motion. So obviously it has to be sucked through the straw, which is what's the right term for being sucked? Which is but I would be sucking it. But sometimes if it is not, it goes through. There's a particular term, but mechanics, car mechanics sometimes do suck it. If it doesn't happen, the oh, I'll get next video. All right, whenever I get the next video, I'll tell you the exact term of flow. On its, if you just put it in a tube in water, it goes through because there's a change in pressure. There's a particular term for it. I'll get back to you on this. All right, and but eager students can look it up. Suction, I think suction flow. All right, suction flow. This, of course, I'm adding the suction. All right, so those two did not come up. This was the right consistency. So 4 seconds running. So that was 12 seconds. 12 seconds is the right time for the right ideal tropical cocktail. All right, the better is on the thing. The speed of high speed, 4 seconds, 12 seconds, high speed, and yeah, and if you want to get really technical, um, this Vx would come from the calculation of the what amount of voltage, etc., which goes into it, which goes into making the mixer. So but that's beyond the scope. For some, it's a thesis topic for somebody who's keen on it. And here goes. So del v, so 3 theta del v square velocity gradients. There we have it. So this would be x component, y component, and so plus there's no vx. I can there's no vx plus vx. So you would have. I'm going to look at y direction only. Rho open brackets del vx by del t plus vx. Vx tends to 0 plus vy. So from the calculation, from the thing. So del vx by del y, again I have it, plus v, and the z component goes up, is equal to minus del p by del y. And I calculated the del p change in shear stress by del y. That would be, I have the mill, and it should all be okay. And plus mu viscosity, got to measure. Actually, you would have a viscosity meter, I think, but one of those experiments which we did in the 11th and 12th grades, the Stokes viscosity, the Hagen-Piezool, and the rest. And so del square y, the del square vy by del y square, I would have to add and see if it all matches. If this is equal to this, then plus rho g1. All right, then I have done my fair bit in momentum transfer, and this video I am dedicating to Professor Taras, Professor Chang, and all my undergraduate professors who taught me momentum, heat, and mass transfer. And in more ways than one, I learned the importance of it in my life. All right, there you go, signing off. Last one. Oh my God, my sexaholic motion, shopaholic, all this. All this I've bought. Sexaholic, I have a. So last one. I'm not going to be doing this. All right, or should I? Maybe turn it into a paper. That might be a good idea. All right, so here goes. Let's get the music on Spotify. Sorry, it's a little not put together, but I lose the engineering thinking, right? Mostly I'm all, ready for my Francis.